Hey YouTube, this is Rishika. Firstly, I need to apologize all you folks because it's been pretty long time. I've not posted any video on DataStage. So yeah, after a very decent time of hibernation, I am back from all the work. I need to do all the pending work and all those things. So I think I'm gonna make videos continuously from now on again. So yeah, since it's been a pretty long time, I know I have been dealing with the remaining processing stages as far as I remember. But since it's been pretty long time, almost close to a month, I mean for not posting video, I thought I would pretty much start with the simpler yet important stages. I'm going to cover up the development and debug stages first, and then go on to the processing stages where we left. Okay, because I thought it would be easy because it's been pretty long time, and I don't know. I'm not sure if everything is like goes well with the machine, with the virtual machine and all those. And most importantly, I need to get back to the farm, so I don't want to mess up like the big stages and mess up something. So I thought I'd give a shot to the simpler stages, but it doesn't mean that they're not important. Even though they're simpler, they're very important while designing and developing the jobs in the real time. Okay, and like in normally while you practice, you just don't use this because I mean practically when you're trying to do it on your machine, you don't see much use of these stages. But when you're dealing with larger data sets, let's say like 10 million records or like 40 million records, then and while you're designing or developing the job, these development and debug stages comes into handy. Because let's say you're dealing with some 10 million records. Okay, so and someone said something is wrong with a few of the records, or something is wrong with the data. So instead of trying all the 10, and you don't know where exactly it's happening, right? So instead of trying to write all the 10 million or whatever 40 million records to the output, we can just have like a few of these stages and know and see how where exactly is like going wrong, and what are the records that are like going well, and what are the records that are not going well, and what are the on what partitions it's not going well, and all those kinds. Okay, so at first that's pretty much about the development and debugging stages. It's basically debugging, right? So you're looking for the debugging errors, so you're trying to debug the errors or the debug the problems, right? Okay, so yep, that's pretty much about this palette, this category on this palette here. Okay, so I thought I would start with the head stage. So head stage, right? Head stage is nothing but this Unix command. If you are familiar with a few of the Unix commands, like the basic commands, you I think obviously you have dealt with head command too, head and tail commands. So it's similar to the head command in Unix operating system, but instead it's not just like the command, but it's the graphical interface that gonna communicate with the DataStage application. Okay, so that's it. That it's just a graphical interface thing that gonna communicate between DataStage application and the Unix server. Okay, so yeah, basically it runs on orchestrate command, right? Do you remember everything? Hopefully yes, I guess. Okay, so I'm gonna start with head stage. I'm gonna first give you a little brief info on head stage, and then get into an example showing all the properties and how exactly does the head stage comes into handy while dealing with larger data sets and all that. Okay, so yeah, let's begin the theory part. So head stage, basically obviously it's a development and debug stage. It can have only a single input. Only one input link can be drawn to the stage, and only one output link can be drawn outwards to, I mean, okay, only one output link can be drawn outward to the from the stage. Okay, so only one single input and one single output. No other. See, it doesn't accept any other links. Okay, so basically it's the main operations of the head stage is it basically it doesn't change or it doesn't change or it doesn't transform the data, but instead it just performs the copy operation from the input to the output, right? Because when you're trying to use a head stage, nothing is being transforming except that whatever the rows exactly in the same way, they are being copied to the output. Okay, so now you might have a question. So what is the speciality of head stage? Don't we have like a copy stage for performing the copy operation? Yeah, we do. But the thing is, we can customize what rows we want and what partition, only those rows on one single partition and just rows on like two partitions, and what exactly which rows are you like looking for, or random, and all those. If you want to skip some rows, you can just have that thing and all that. So basically the main thing about this head stage is you can have what do I say, you can perform the copy operation, but instead you can customize the copy operation to you can it's not just any it's not just copying or dumping the columns from input to output. It's something more than copy operation, right? Because you can skip the rows, you can choose how many number of rows per partition you need to write output. Because if you're dealing with 10 million records, it doesn't make sense for all the records to be written to the output, right? Because it's waste of resources when you're just trying to know what's the error or what might be the possible error while dealing with the rows. Okay, or if you have like doubts over some of the rows, you can just have that those things, right? So when you're trying to deal the default number is always 10 here, but when you're trying to read, you can have like 400 rows per partition. So obviously 10 or 40 million records of let's say you have four partitions, and 400 per partition, you're trying to read only 1600 rows, right? Out of those 40 million records. So performance is greatly enhanced, right? So and resources are also used less, right? Because obviously you're dealing with only 1600 rows, right? So yeah, you can customize whatever thing you have, and it's all partitions. Yeah, if sometimes what happens is one partition works well, but the other partition doesn't work well, and you're not sure of that. You're not sure if that particular partition does work well or something is going wrong on that partition. So you can just choose your own partition here. Whatever doubts you have, you can just choose your partition number. And you might be wondering that if this is, can we only choose one partition at a time? No, we can choose any number of partitions as per in the project. See, this blue thing it's blue thing, this means that it's a repeatable property, right? Repeatable property, you can have any number of those. But to have this partition number to be customized, this all partitions must be false, right? Because if it's true, it doesn't make sense to choose the partition number, right? Because you're telling it whatever the rows just all partitions are true, right? So yeah, that's it. So basically to sum up this, okay, let's first focus on these properties and then sum up the head stage, so that would be more clear, I guess, for you. Okay, so yeah, now this all rows after skip means, so all rows after skip is one property, so which means it has only true and false things. Okay, it doesn't have any, it's not a rocket science, it's just like simple true and false things, that's it. And putting up numbers from whatever the requirement or whatever the basically your thing is. Okay, so all rows false and true. Basically what this property do is, it's basically allowing us to copy all input records from the to the output data set. Okay, so now you might be wondering of what's its after skip, right? So all rows false means you're telling DataStage that I don't want all rows, but instead please let me choose how many number of rows per partition should be read by my head stage. Okay, so by default it's always 10. Let's say okay, set to default, see it's 10, right? If you say 9, okay, and then click on right click and then set to default, see it's 10, right? By default it's always 10. So you're telling DataStage that all rows is false. So for now just forget after skip. It's another thing which comes after after we choose the skip property. Okay, all rows is equal to false means you're trying to what you're trying to say to DataStage is, I don't want all of my rows to read. So it got that. Okay, so but now it needs to know what rows you want to read, right? So because you don't want all rows to be read, now you want to customize how many number of rows per partition. It's not just any number of rows in the whole data, it's per partition, right? Head stage is always per partition. Okay, so it's per partition, so you can now customize how many number of rows you need to choose per partition. So apart from those these two properties, we do have other two properties called period per partition and skip per partition. Okay, so period per partition, first let me explain skip per partition. Skip per partition means you're trying to say to DataStage that you want to skip a specified number of rows, like let's say 10. You want to skip the first, not any just 10 but the first 10. Okay, because it's a head stage, the first thing, head is like top, right? So first, remember that way. So it gonna just skip the first 10 rows and then read all the rows. Okay, so it gonna, okay, this should be true then. Okay, so what happens is now it gonna skip first 10 rows. Okay, and it starts from 11th row. Okay, so that's how it's gonna operate. And the next thing is period per partition. Period per partition means it copies every whatever the number you give here, let's say 2, it copies the second row of copies every second row in whatever the rows here we have here. Okay, let's say we have 10 rows here, so it copies every second row. So 10 rows means it should have like 5, right? 5, 2, 4, 6, 8 and 10. So it copies second row, 4th row, 6th row, 8th row and 10th row. But ultimately when you try to run the job, it doesn't have 5 records written to the output, but instead it have 6 records written to the output, because it always starts from the first one. Okay, so I mean it's still 5 I guess, because it starts from the first. So first and then counts the second and then counts the second row. Okay, so if you have like say 10 rows, so and you're trying to skip okay, let's say you have 10 rows and you're trying to skip the first 2 rows. So how many rows do we have now? 8 rows, right? So 8 rows, out of those 8 rows you get the first record. So you get the first record of those 8 rows, and then third, and then fifth, and then seventh, and then ninth. So ultimately you get 5 rows. Okay, four rows. Okay, I'll let you know by example. It probably creates confusion I guess, but I'll make it clear with an example. Okay, and that's pretty much about this rows category. And now moving on to the partitions. All partitions true. So it means true means you're trying to copy or you're trying to perform operations from all the partitions. And let's say you're sure that one partition is performing good, and the other partition, something is going on wrong with that partition, or something is going on with the partitioning technique we choose or something. Okay, so then if you choose false, then the sub property comes into action. So you're trying to say that I'm not interested in all partitions, right? So whenever you're saying that you're not interested in all partitions, you need to give what partition number or what partition you're interested in, right? So whatever the partition number, so if you remember, the partition number always starts from 0 as per the project. I mean as per the project in your environment and all that. But I mean honestly it's mostly start from 0, even though if let's say you have 2 partitions, the first partition is numbered 0 and the second partition is 1. Okay, so that's how it's gonna operate in the real time. Yeah, that's pretty much. And you might be wondering what happens if we have like more number of partitions and we are trying to read, let's say you have like 4 number of partitions and you're trying to read only from 2. So this thing blue here, it shows it's multiple times, right? Because that means that it's a repeatable property. So you can choose any number of partition numbers here. So when you click on these partitions, it has available properties to add. So go on, you can just add whatever the number of partitions you want to try to read. Okay, so yeah, that's pretty much. And The other thing is, if you want to know what partition number the record is, it might be a good idea to use the transformer stage and use the system variable partition num, but I'm not gonna use the transformer stage again and make it complex. So for now, because we have only obviously two partitions, it would be easy for us. So what I'm gonna do is I'm gonna choose, okay, let me just first dump the data and then explain you. Okay, let me check if my data and everything is in place, isn't good. Oracle, as far as I remember, my username and passwords, Scott, and this, and generate SQL, yes, and EMP. Okay, now let me just test the connection first, because it's been long time. Okay, connection was successful, good for me. Okay, yeah, everything is perfect. So this is the data. Okay, so okay, everything is good now. Let me click on the head stage and set everything to default. Okay, and let me just remove remove all this and perform basically whatever is like the basic thing. Let's perform that first. Okay, so now input. Okay, we didn't dump columns in here, right? That's what happens if we give a long break. Load, and then EMP table, and then okay, and yeah, I'm interested in all the things. Okay, it's done. Now let me okay, so now what I'm gonna do is I'm trying to read only, there are 14 rows. I remember there are 14 rows in this EMP table. So what I'm gonna do is I'm trying to read okay, all rows. I'm not interested in all rows, but let me know if the rows are going to the output or writing to the output well enough to, so that I can transform it later, right? So if you just want to know that, so let's keep it 4. Okay, so it's 14 rows. So 14 rows means because I have two partitions on my machine, it's 7. They're gonna split up to 7 and 7, right? I mean, it's just load balancing thing. It's not that I'm gonna choose any other hash partitioning or something. That might be like 8 on 7 or 6 and 9 and all that. But let me choose an even partitioning. So 7 and 7, right? So 7 rows will be read from each partition, but now I'm trying to read only 4 rows from each partition. I'm not trying to read 7 rows, only 4 rows. So how many rows should I get to the output? It should be 4 and 4, right? Because I said 2 partitions is on my project, so it should be 4 rows from first partition and 4 rows from the second partition. So obviously 8 rows should be returned to my output, right? Let's see that if that's going well. Okay, and now what I'm gonna choose is to make it little easy for us and to make it like easy for you guys to understand. I'm gonna not leave it auto, but instead auto means we don't understand what partition it's going to, right? So let me choose round robin, because I'm doing it round robin because, okay, let me choose sorry, let me remove this. Okay, let me remove this too first. Okay, EMP number. Okay, so I'm trying to use round robin because round robin partitioning technique, if you remember, the first partition goes to the first row goes to the first partition, second row to the second partition, the third row again to the first partition, and the fourth row again to the second partition, right? So we know that whatever the first row is seen, that's written to the first partition, that's through the first partition, and whatever the second row we see, that's because of the second partition, right? So we can know, even though we don't have additional column like additional column name, system variable like partition num and all that, we can still know what's happening, right? So that's the reason, to make it live and to make our job and to make you understand easier, I thought I'd choose round robin technique. Okay, and yeah, that's it. And columns, yeah, everything is good. And then now let's map it to the output column. So I'm trying to read all the columns. Okay, so everything is good. And why is this runtime column propagation, it's clicked? Okay, let me remove this. I think it's been a long time I didn't use this, so probably runtime column propagation is turned on. Okay, let me uncheck. Yeah, I unchecked it. So now browse for file. It's still the same file, so it doesn't matter how long I have been not doing videos, but still it's the same ds files. Okay, so now everything is good. So let's compile and run the job and see if everything is good in place or something is happening, errors or something. Okay, so if you remember, we are trying to read four rows per partition, right? So out of the 14 rows we should get 8 rows. See, and yeah, we are successful, we got 8 rows. So 8 rows means 4 rows per partition, right? Now okay, let me do one thing. Let me first take a screenshot of the data, actually screenshot of my input data, so that we can compare what's exactly happening with the output. Okay, okay, I did take the screenshot now. Okay, let's close this and now open the data. Okay, so it should be 4 records. We didn't do anything. What we did was we just ignored all the records and we're trying to read only the 4 records. It's not just any 4 records, but the first 4 records, because of the head stage, right? So head stage means whatever you do, it's from the top. Okay, so now let's compare it with this output data. I mean, sorry, input data. Okay, so 7369 this first one. Okay, and 7499, so this is the first. Okay, so it's per partition, right? So 7369, let me take a new notepad too and make it easier. So partition 0 and partition 1. So what's happening at partition 0 is, as per our input data, 7369 7521 7654 7782, sorry, 7788. So okay, sorry, it's reading only the first four things, right? So this is the first 4 things. Okay, and partition 1, what it is reading, 7499 7566 7698 7788. So see here, so what happening is, the first record here, it's going to the first partition, right? And the second record, it's going to the second partition. Third record again to the first partition. Fourth record, second partition. Fifth again to the first partition. Sixth again second partition. Seventh first partition. Eighth second partition. That's it. Because what we said was we are trying to read only the first 4 rows, right? That's the reason it stopped at this 7788, right? So yeah, that's it. That's a head stage. So it doesn't change anything. It's just trying to copy the records, but just 4 records per partition. Okay, so yeah, that's pretty much about this. And now what we're gonna do is we're gonna add these period per partition, and we're gonna add this skip per partition too. And for ease, let's make it easy for us. I don't want to confuse you guys, so let's make it easy. So now what I'm trying to do is I'm trying to read all rows, but after skip. So whatever number I specify here, that number gonna execute first, and then it gonna return all rows, right? So okay, let me now say I'm gonna try to skip let's say I'm gonna skip 3. Okay, 3, the first 3 rows I'm trying to skip, and the period per partition, let's say 2. Okay, and now let's change everything. So now I'm trying to read only from the first partition. So partition number is 0. Okay, so what I'm trying to do now, let's just assess the data. So what I'm trying to do now is I'm trying to read all the rows, but after skip, right? So whatever rows so after skipping the 3 rows, after skipping the first 3 rows in the data per partition, after the skipping the first 3 rows per partition in the data, those rows, all rows will be returned to the output. Okay, and what are written are, and then it performs period per partition. So out of those rows, it gonna write every second record starting with the first one. So obviously the first one will be written, and then after that first one, whatever are the every second record will be written. Okay, so now let's again assess the data. Okay, so I'm trying to skip 3 partitions and period. Okay, let me just do that. Okay, period per partition is equal to 3, and skip per partition is equal to, period per partition is 2 actually. Okay, and skip per partition is 3. Okay, and all rows after skip, it's true. Okay, and partition number, I'm trying to read partition number is 0. Okay, because it's a first partition, so I'm trying to read from the partition, only one partition, that is partition number 0. Okay, so this is it. So now let's just give our data and then see if we are getting the right concept or not. Okay, so now what happens is, okay, I'm sorry. Okay, so now what happens is partition 0, right? So 0, partition 0, what are the records? We are trying to read all the records, right? So what are the records? All the records: 7369, 7521, 7654, 7782, 7839, 7876, 7902. So these are the records normally which are written to the partition 1. These are the 7 records out of those 14 records. These are the 7 records that are written, that are going through the partition number 0, if we choose the round robin technique as we have used in our job, right? So okay, so now what is this? All rows after skip, right? So after skip, so what is the skip per partition? Skip per partition is 3. So the first 3 rows are gone now. Okay, so the first 3 rows are gone. So now after the first 3 rows are gone, all rows will be displayed, right? But we are not interested in writing output all rows, but we are interested in writing period per partition. So period per partition is 2. So what that means, that every second row will be written to the output starting with the first. So the first row will be obviously written to the output. Okay, so how we get output is, how we can expect our output as per the as per this properties is, the first thing is obviously written, because period per partition, it copies or it writes every second record to the output starting with the first. Okay, so the first record is written, and now the first record is written, it checks for the second record. So what's the second record? This is again the first one and the second record. So every second record, right? So now this is the second record. So now 7876 will be written, and now again it checked for the second record. So this is again first and there is no second record, so it stops there. So obviously when we have all these kinds of properties set up, the output should have only 2 rows, and these 2 rows will be employee number 7782 and 7876 if I'm right. Okay, now let's see if we are right or not, and if we get our concepts right or not. Okay, so 2 rows are written, so obviously 2 rows, right? So that part is right. Now we want to see if those 2 rows are same as our output 2 rows as we expected, or something else. Okay, let's see. Okay, yep, 7782 and 7876, right? Absolutely perfect. So we got that right. So we got our concepts right, and hopefully I think I made it a point. Okay, so that's all in this video about the head stage. So let me just finally sum up all the head stage operations that can perform. Okay, so basically it just performs a copying operation, but yeah, that's one thing. And the other thing is, you can obviously, it's not just copying, you can obviously choose the partition number. Like you can basically choose what rows on the which partition are to be written to the output. So you can customize, you can know, you can actually mention what partition you are interested in to read the records, or what partition, the partition from which the rows are copied. Okay. And the next thing is you can obviously customize which from where you want to start writing output. Like basically you want to you can customize the location of the rows to copy. And the last thing is you can obviously skip, right? So basically location of the, location means it's just period thing, right? So you can customize, if you want to write every second record, you can just have two. If you want to write every third record, you can have it too, right? But it's not just third record, it starts from the first. So first record is written and then it counts the third record from there. Okay. So and the next is you can obviously skip the records per partition. So everything is like per partition, right? So yeah, that's pretty much about this head video, head stage in DataStage. So probably it's not a big deal, but yeah, they're really coming to handy when you're dealing with like huge data sets, amount of data sets. So yeah, that's pretty much. So in my next video, which I'll be pretty posting pretty soon, I'll be dealing with tail. So once I'm completing with all these development or debug stages, I'm gonna jump on to again the processing stages, whatever stages we have left incomplete. Okay, and thank you guys, and thank you so much for watching, and keep subscribing to my channel. It's tutorial. Thanks.